I think that I shall never see a problem lovely as a tree. I'm Ray Myers. Welcome to Craft versus Cruft. It's been a little while since I've done a live coding session on here, and I want to do those, but I also don't like doing these tiny kata exercises, these kind of artificial scenarios, because the types of challenges I like to address in this channel come with software engineering in the wild, legacy code bases. If you demonstrate a refactoring technique on an artificially small example, it's not always clear how to apply that in a real situation. But at the same time, the larger examples that are more realistic tend to just make really long, meandering videos. So not really sure how to square that. Going to keep working on it. Hopefully we got a happy medium today because I am in the process of adding some features to this tool called TOC-Lang that I created a while back, which is a diagrams as code tool for theory of constraints. And what I'm doing is I've decided I want to change the grammar of the language that I write these diagrams in. Now that I've used more diagrams as code tools and have seen, which ones I really like. And not a lot of people use this tool, if any, besides me yet. So there's not really going to be a problem with backwards compatibility. Otherwise, it'd be a whole different exercise of how we deal with that, perhaps with some kind of, auto migration script. But I don't have to deal with that just yet. I can just change it, I think. I'll show you what this tool really is in a while, but basically we're going to go from syntax that looks like this to syntax that looks a little bit more like these other examples, which I've already migrated to the new style that I want to use. And the reason I started using this format is I used a diagram as code tool called D2, and I really liked it. If you've used Mermaid.js, it's the same basic direction, but I just like their syntax a lot better. I find it very uniform and intuitive, and I want something that more or less corresponds to that when I'm doing my theory of constraints diagram. So that's why I'm gonna switch this over. So here are some of the things we're going to be doing today in a relatively short amount of time. So if you're interested in doing some of these things, then this is a good video for you, right? We're going to be parsing a domain-specific language. So I've got a parser for an old grammar of it, and I'm going to update that grammar for the new syntax I want. So you get some exposure to what that looks like. We're using a tool called PeggyJS. Really, this uses the same kind of BNF, Bagus Noir form, I think that stands for. Same kind of notation you see in a lot of different tools that use grammars such as Antler, such as Yak and Lex. One related to Peggy that I thought was really interesting is Langium. Actually, this is a newer approach, and you can check that out if you like it. They got a really easy, spiffy way to play with the grammar, play with the content, see the syntax tree that comes out of it. PeggyJS also has something like this, and this is just super cool if you're used to more cumbersome ways of developing with grammars. We're also going to do a little bit of theory of constraints, which is a systems thinking paradigm. The specific notation I'm trying to follow with this in terms of the diagram that it produced, I want to be consistent with logical thinking process, which is a formalization of theory of constraints that this fellow named Bill Detmer did. If you'd like to dive more into theory of constraints and learn what that's all about, I do have a couple videos on the channel introducing it. I'll link those in the description. Also, I'm going through, in order to brush up on how these diagrams are all supposed to look and work, in order to make this tool, I'm going through this Udemy course by this fellow Thorstein, who's an expert in this, has worked extensively with Detmer, who created logical thinking process. It's called Thinking Sharper with the Logical Thinking Process. That's on Udemy. Another place, especially for theory of constraints applied to software development, where I've learned a lot is from Tameflow, which is a theory of constraints hybrid system by Steve Tenden, and there's a forum called Tameflow Circle. Also going to do some approval testing, also known as golden file testing, which hasn't been used in this project yet, but I think would be a really good fit. So I'm going to bring that in using a library that's available for pretty much every major language by Llewellyn Falco and others. Of course, we're going to be updating some code. So you know me, that means we're going to be doing some refactoring. Obviously, this is a diagrams as code tool. So that's another thing that's in play here, and this will be in TypeScript. It's a React app. Currently, I want to eventually make it command line available as well, but I don't think the React front end is going to come into play that much. So basically, this is what you're going to see today. So the first thing I want to do is go into the repository and make sure that I've updated the documentation. We've got this RFC for the syntax I want to have. This is how, for instance, the evaporating cloud diagram, which is my favorite thinking process in theory of constraints. This is how it used to look, is more kind of Englishy. I was inspired by the text adventure game language called Inform 7, which is why I made it look like this. But after using more diagrams as code tools, I decided I wanted it to look like D2. So with just a little error I'm going to fix here where I haven't migrated all of these. We want, node name, colon, and then a label. It could be quoted. It need not be. So we'll give both examples in here. In the evaporating cloud, the node names are kind of static. They're always A, B, C, D, and D prime, but you can name them in the other types. So let's go to the new one. We haven't done problem tree yet. I've already migrated the other one, so hopefully I should more or less know what I'm doing here. So we've got still the old format. So I'm going to leave a comment for historical purposes, similar to one I left before. Saying, hey, it used to look like this. We've changed it. So let me grab this and we'll just leave a similar comment. In this issue, historical note, the RC1, release candidate 1 syntax is now abandoned in favor of release candidate 2 patterned after D2-Lang. We'll just take this out and plop this in. And so that's shown, okay, this was the old one. We've kind of documented the decision record of this, and we will change the syntax right now. So UDE bad is bad user experience. What I'm saying there is that there is a node of type UDE undesirable effect, which is the problem in a problem tree. We're going to use a naming convention on the node ID to indicate it's a UDE now, and then just colon, and then the label is the new syntax. C was condition, and a condition is now going to be the default type of node. So we just need cluttered colon cluttered interface, and we've got something equivalent. Then we've got a causal relationship. So those are the basic kinds of things. We've got nodes, and then we've got relationships between the nodes. So let's see what that looked like when there was a one thing causing another. It looks like the cause goes an arrow to what it's causing. So if the cause is an arrow to what it's causing, then we're saying that cluttered needs an arrow going to bad user experience. So that'll look something like that. And I'll just continue converting these. This is just a node. And then we have, okay, this is the one part that is a little different. UX and features cause cluttered. So what I can't do is just say UX arrow to cluttered and features arrow to cluttered. Because you notice there's an and. I can't just have two independent arrows, because in the notation, as I understand it for a problem tree, that would indicate like either of these things could independently cause that. But what we want to depict is that the two of them together are what's sufficient to cause cluttered interface. So that means we need new notation. This is the one place where I need to differ with D2's grammar, because there's no way for it to describe this node connects to this one with like an AND relationship. So we're going to deviate and otherwise stay in a subset of D2 grammar. And this is just an executive decision, right? Like I could do UX and features. I'm going to use, it seems more natural if we've got an arrow notation already in this colon, so that we use a symbol rather than like the word and like Python. So I'm just going to use your default logical and like you would see in most programming languages. Could be something else, right? Could be a plus sign, could be whatever, but to me that's the most intuitive. So we got another condition here, that's just default node. We'll just label it like that. We can put quotes over that one just to show that's an option. Okay, we haven't seen this node type before. This is a fact of life. FOL in problem tree is a fact of life. So it is basically a condition, that might be needed in combination with some other condition to cause something, but it's not one that we change. It is something that just is always going to be the case about our context. So kind of as a judgment call, we decide that some of our conditions should be labeled fact of life. And again, I'm going to do that with a prefix, just like with UDE. So we're covering that kind of with a naming convention rather than explicit notation in the grammar. Again, we've got a joint cause, so I'm going to put the feature over here, and it is caused by sales pressure and enterprise requests. And then we have another new node type, I think this is the last one, DE, desirable effect, right? So it's something that we do like instead of a UDE, an undesirable effect. So again, just a simple colon there. And one more causal relationship with an and. So I think if I've done all this right, that in the end, we should be able to run this through a unit test and it will parse this example. So this is our new proposed syntax. As you see, we can go over to here for the full grammar specification, and that's exactly what we're going to need to update. This is a fork of VS Code called Cursor, by the way, that has some AI features. I don't know if we'll use them today. And so pull up the grammar. And we don't have highlighting for this, but no matter. And we can just go to PeggyJS and pull up their playground, and it is a really nice way to edit these grammars. So if I pull up an example from my examples file, and we've got a problem tree, and it should parse because we haven't updated the grammar yet, and this is the old one. What we want is that this parses, right? And right out the gate, it doesn't because the identifier is not valid, but it could be, it should be. We just need to say that identifiers can include underscores, and that should handle that. So if you don't know BNF notation, this is going to be a little confusing because you're looking at PeggyJS's variant of BNF notation, but we've got grammar production rules and then the things that can match them. If you don't follow that well enough to see what's going on here, that would be a good thing to go learn about first. So let's see how the statements looked before. We take just a series of statements separated by line breaks, and statements either comment line. Comment lines are pretty unchanged. They're with a hash like Python and like D2-Lang, so we're keeping that behavior. And then we have either a label statement or a cause statement. So I'm going to say those are now a node statement and an edge statement to be a little more uniform, because that will just describe an arbitrary graph, and these are all going to look a little more like each other, these grammars now. And so otherwise, the intent is the same. An edge statement is for causation in this dialect. So what's a node statement look like? Well, before it had the type of node and then an identifier and then is and then a string. It's not exactly what it is now. It's an identifier, which could have one of these as prefixes, defaulting to this one, or it could, have no prefix. And that's not going to be handled at this point. That's, you're going to parse an abstract syntax tree, an AST, that will include the identifier, and a later step is going to identify, by convention, this prefix we should do this with. So this is no longer in the grammar, is what I'm saying. Makes the grammar simpler, maybe a nice thing. So instead of is, I'm just going to make this a colon. And then we have a string. Is that right? Well, let's see. It's failing on this B character here because it thinks there should be a quote. Because I said it's a string, and in this grammar, a string begins with a quote. Well, it could, we allow that. Like, that's one way we could input this. But also, it could not have a quote. It could just be free text. And the advantage of having the quote version is you could have, a multi-line string. But so we need more options here. So I'm going to make a new type, which is called a label. And it could be a string. That'd be totally fine. But it also could just be some text. And what text might it be? Well, not a quote. That's not really true anymore. Not an open paren. That's for sure. And probably not a new line. Is that right? Yeah. Yeah, not a new line. So let's see if that works. All right, type is no longer there, so we don't need that. All right, expected colon and or cause are optional white space, but found left angle bracket. That makes sense because we haven't updated the edge statement yet. So let's make an edge statement. It does still need to begin with an identifier, not a list this time. I don't think we have this notion of an ident list, but we would have a single ident. And we could have this left connector. We could extend this to allow, it to be specified in multiple directions, but right now I'd like to just keep it uniform. So we have identifier, we have a direction, and with an optional space here. And then we have another identifier. So I'm going to call this the from ID and the to ID. Now we will eventually need like potentially a list of and separated from IDs, but not right now. So let's start simple here, and let's say, okay, we've got this to ID. The type of this is an edge statement, and the type of the other one, actually, I do want to reintroduce that, but just make it general. The type of this is node. Okay, and it's going to be from ID and to ID is what we need to pass through to this is going to become part of the abstract syntax tree. We'll see that in a second. And yeah, this is looking pretty good. Now let's see how this works here. I'm going to comment out ident list, make sure we're not referencing it anymore. All right. So yeah, this is worked up until the point at which we have the and sign. So let's just get rid of all those lines and make sure this parses as is. Yeah, and this is that abstract syntax tree that this is now is both parsed the grammar and then assembled the things that it captured into an AST for us, which is something that's really nice about Peggy, is you can define all that in one place. This is not the approach taken by Antler, and Antler is probably right for the scaled up use case where you often will need multiple different AST transformations, and so you want to keep the grammar separate. You don't want to intermingle that. You might need multiple types of ASTs, might need different languages that you're going to write them in, and you want to use the same grammar for multiple. I mean, they have all sorts of use cases where this won't work, but in the small, this is very handy to just edit them all together. I'm going to intentionally introduce a syntax error so I can get back to the editor so it seemed to hide it from me. And let's now uncomment those, because we will need to parse these ampersand, these and edges. So what's that going to look like? Well, now we need to be a little bit different here. We got to use some more features of how these grammars are specified. So I'm going to say, in addition to this from ID, I'm going to say, like, I can have more from IDs that start with that first one and then add an ampersand or two of them, and again an optional space. Let's have that here too. And so we've got like more from IDs. They're going to be here, and then like we could have what are more of them? Actually, we could have 0 more of them. So I'm going to use an asterisk in the old BNF notation to indicate that. And so this should match the old ones, and it should match new ones too. So let's see if these match at the moment. Right, we've got a problem here, but that actually is a problem in the text. Okay, perfect. This matches, but it doesn't actually do what I want yet. We haven't done this correctly yet, because if we go to one of these edge lines with an and, so for example, none of them have more than one from ID, and we can. This is really a list. It should be now. Let's go to Peggy, the documentation here, and see how we do that, because I've just forgotten how you accumulate lists. Is it parsing the limited list of items? Yes. So we've got head and then tail, and since they're inside a loop here, they're using like an @ sign to add to the tail. So it would be convenient if we could just add to the same list, but apparently, it said in grammars created before the repetition operator, and then you would destructure them to jam them on one list. But what I didn't know is in 3.0 they added an easier way to do this. Well, this is kind of strange, but I guess this is an idiomatic way to do it. It looks like they're doing like open pipe and then ... and then the delimiter. So I guess let's try that out. We've got the playground. We can experiment with it. Very strange notation. I'm tempted just to use the old way, but I want to try this out because I've done the other one before. So we would say we want an ident, and I think I do want to give this one a name because we've got also the two ident, right? And we'll give it this comma, and then what we want our delimiter to be, which is not with a comma, but with a double and. Okay, and so from ID should now be an array. Is that true? Yes. All right. It worked. Worked pretty well. And let's just make that plural just to make it obvious. So I think this this grammar is now in a pretty good spot. They've got this. Looks like I had some cruft here. I don't need a percentage in this grammar. I think we can drop it in, and this should give us a failing test, because we've tested this grammar with previous examples from the old syntax. So we'll have to update those tests. In essence, this was the that example was the test for the grammar as we were developing it. So now we have to update our test to match that. Fire this up. An npm run test should take care of that. This should break on me now. Yeah. Problem tree interpreter test. So let's fire that up. And this will mostly be toilsome. You know, this will just be a matter of changing over the grammar from before. So with only UDE, let's do this twice. Now it looks like I did an array of test cases this time. That's kind of nice. And the other ones I have the test just hard coded each. I'm going to make two versions of this one now, actually. One with quotes and one with not. Quoted label. All right. So let's see if we get rid of all the other ones, does it pass now? Looks like there's another case here that isn't covered by that array. We'll just migrate that as well. And C causes D is going to be D arrow C. So this is node type with the UDE prefix. And this is again node type with IDC. And this is edge type with, I guess, a to ID and then from IDs as the causes. Still failing. Okay. Now the expected semantics is now the part that's broken. It looks like so after the AST, we haven't talked about this yet. After it parses the AST, which is doing now correctly, that AST needs to be parsed into what I'm calling the semantics, which is the notation that the thing that actually generates the graph is going to look at and take. So basically, as long as we're still generating something that looks like this, then we won't have to change any of the diagram code. So I don't actually want to change the way this semantic structure looks. I only want to change how the AST is converted into it so that it will still look the same as it was. So that is going to be over in the parse tree, parse problem tree semantics. Okay, we got some nice TypeScript here, maybe not so nice. And we said if type is C, okay, that doesn't work anymore. Type is UDE or DE or FOL, like these are all type node now. And we have to be able to handle this case and this case. So the annotation, I suppose, is going to be, that's going to be what's dependent on what prefix it has. So we're going to need to get an annotation out of here. Find node annotation. This is the concept I'm getting at here. And it's going to be based on the node's ID. And we'll say that the annotation, is get that out of the node's ID. And that could be none at all, right? In the case of condition, it should be none. Or in the case of UDE or DE or FOL, it should be like any of those things. So, maybe we can generate this here, actually. If ID is begins with UDE or FOL or DE, case insensitive, that's important, because I think if someone does lowercase UDE underscore, it probably should still work. If they don't do underscore, maybe it should still work too, right? So I'm just saying begins with one of these, case insensitive, then return that those. Otherwise, return null. Or better yet, undefined. Is that better? I don't know. All right. So it has generated me a method within a method. So very bad syntax support from everyone's AI tool still. But yeah, if it matches beginning a string that lowercase, I think that is a valid way to do this. And then pulls it out to uppercase. Yeah, I think that's good. We're reusing this pattern. So I would extract that. If I just do an extract refactor here. Yeah, nice. Okay, and then I just have to. That might work. That might find the node annotation, and then we don't need multiple ways to handle this. So then we have another thing, which was cause. Can we run the test again? Will it show at least some of this is working right, or will it just blow up? Yeah, we're getting UDEB back, so that's cool. I think it can be called UDEB. I don't think the ID actually gets displayed, so I think that's all right. Typically, we would want a label. I suppose in the case of the absence of a label, do we just display the ID? I don't know. I don't think we handle that case right now. So, edge is the other type we need to handle. Okay, what have we done here? It's effect ID. That's not really true. It's the to ID is the effect. And I'm going to keep calling it effect key. Cool. So statement causes is really the from IDs. So if there are from IDs, then statement from IDs, and it's going to make a combined ID out of them that's still valid, I think. Yeah. Cool. So then it iterates over the causes and adds edges for each of them. So we'll take these from IDs here and iterate over them, still call it cause key. Yeah. And then most of this doesn't need to change. So let's see what it looks like now. All right, now only the keys are different. I think we decided that's okay. Yeah. So let's try updating that. UDEB is the key, and UDEB. And in the semantic tree as well. That key. Okay, cool. So except for the cases I commented out, they're all good. And next, we could take all these, right, and just migrate them over and say, like, given this text, I want this output. But what we're really doing here is approval testing. And there's this great library that I want to drop in here that will automatically keep track of the snapshots that have been approved and kind of, make this process a little more maintainable. So we just saw what it looks like when I, I've already just uncomment this and see, okay, what should the result be now? Let me just, update it. So let's look at the streamlined version now. So I'm just going to go to ApprovalTests.com, right? Llewellyn, Falco, and others work on this, and it's just great. There are ones for all these different languages, and I haven't tried the JS one yet, but I've used it in several other languages and never disappointed. So let's get this. Let's just install as a dev dependency this approvals library. Okay, they're saying you can configure reporters in various ways. You know, I'm gonna see if I can get away with not doing that. Just gonna import approvals. They've got it as a require. I assume that I could just import it. Looks reasonable. And then approvals, and this will be clear what's actually going on here in just a second. So we're in parses AST for input. This is what we're going to replace, and we'll just go through each one. And we'll do a verify from dir name and parses AST for input. We'll just give it the test case name. We've already got a name ready. And then we have the result that we want to verify. It says some text, but I imagine this doesn't have to be text. It could just be the AST. We'll see. We could always JSONify it if we need to. And just take out that expectation. Let's see what happens. npm run test. Okay, output text is provided is not a string value, but is type of object. Yeah, so what could it be? Either a string or a buffer that represents an image. So this one, it does have to be text. Verify as JSON. I like that. Let's do that. All right. So what has just happened? This is important here. This is the approved one. There is no approved one, so that's why it fails. And this is the one that was received. So if I think that the one that was received is good, then I can just plop it in there. And we've already looked at it, so we do know that it's good. It's the same one that's already in the test case. And we see the received one is good here as well. So now it passes, right? And if it changes in the future, then it'll fail, and we can just look at it. And you know, it's easier to maintain than when the expected result is just, you know, in your code, and you have to change it willy-nilly. You'll have to take my word for it. This is a lot more maintainable if you're dealing with simple cases of input-output, which is a lot of testing cases do reduce to, honestly. So that means we don't need this expected tree anymore. It's just like, yeah, whatever's in the approved file is what we should verify. So let's take those out. Let's see if that, yep, still works. And now the fun part is we take all of our previous tests and do the same thing. So like, we don't need this expected AST. We don't need this expected semantics tree. All we have to do is make sure that we've still got a valid input case, and then we can confirm, you know, just one time when we run it that, you know, what's in the approved file is indeed something we want. Now this will fail right now because this is this stuff doesn't parse yet. These are bad examples, right? So that it won't save us from that. But this will be all right. Let's try this out now. All right, so it'll fail because we haven't approved any of these results, right? But we just take what we've received and say, okay, the statements C1, C2, C1, C2 are the from IDs, type edge, type node. This is all right. And again, the received one here is right, as long as there was only supposed to be one from ID. Let's check this. Yeah, it says single cause, so that's good. Good name. The comment line Still working. Interestingly, the comment text ends up with a space before it, which I guess is correct. Because, you know, it is hash and then space as it's written. It wouldn't have to be. And great. So now it passes, and we have like a much more maintainable set of approval tests running with this neat little library. Over time, probably what I'm going to end up doing is use these approval tests in the other grammars parser, and maybe even merge the grammars that we're using and only have them deviate like at the stage of parsing the AST into the semantics object. But for now, I think we're at a really good commit point. So let's make sure this actually runs, right? We've done all this testing, but like, wouldn't it be great if this worked on the first try? It won't entirely, because the example it comes with is wrong. But so we'll go over to the problem tree, and yeah, syntax is bad. Well, it should be bad because we need to change our example. Okay, so cluttered is cluttered. Cluttered causes bad user experience. Let me boost the font for you here. UX has this label. And this is caused by UX and features. All right, effect bad, not declared. Yeah, that's true. We've got to address it that way now. So yeah, boom. All right, so that works. And so this will work out of the box if the example is updated to be one that will parse. So I could just do that, right? I could just paste this in, but wouldn't it be great if our test had caught that? You know, that's not great. I don't like the fact that our test did not force us to make sure the example works. So let's also update our test to validate that. Add a new test, example parses. And I'm going to import from examples. Is it like // yeah, there it is. And it's the example problem tree text. So that's what we'll use here. And we don't need an expected one. We just want it to run, and better yet, maybe give a verify as JSON on the final semantics. That could be cool. So we don't want this one to throw an error like the last one. We want example problem tree semantics. It's a good thing to call that. Yeah, and then it should be good. So let's try npm run test. So that should fail and force us to update the example. Yeah, because it didn't even give us like an output. It just threw an exception. So we got the example that it should be changed to here. And we could do a verify at both steps at the AST and then the semantics if we wanted to. We got a result out of it. Actually, like, I don't like this. I'm glad we did this test because we have like the edges all look right, but like we defined all these nodes and nodes isn't there. So how did it work in the interface, but we have no nodes here? All right, and I found what seems to be a bug in the JSON serialization because this is an ES6 map, and it didn't get serialized properly in the approval test. So until that's fixed, I had to do an object from entries on this. Thank you for the chat for reminding me of the syntax to do that. But beyond that little wrinkle, boom, we now have approval tests that are now more rigorous than our original ones were because they include the examples, and more maintainable because we don't have all these received outputs in the inline in code here. They're all in these nice little files that when we run the tests, it manages for us. So great stuff. A good approved example now. And we're green, and let's just make sure it still works when we run it, though I don't know that we've changed the code since the last time it did. Let's get an end-to-end here. And it should, when we go to it, yeah, now it goes to a working example. And yeah, we have a problem tree. Houston, we have a problem tree. Let's add that and say update problem tree to new. So there you have it. And as next steps, what we've done here is take the grammar, and where we saw problem tree. There's also in this app so far goal tree and evaporating cloud. There are two other thinking processes that would need to be added for it to contain everything in logical thinking process. Since we've made the syntaxes all kind of look like D2, I believe these grammars could all be merged, and then the parsing logic could be radically simplified. I'm not going to do that right now, but I'm just going to show you what that looks like here. Because we've got an interpreter, which we needed to modify just a little bit to pass these tests. We've got these three grammars, right? That would become just one grammar. And so these all would become one. And when we're getting a parser promise, it's the same one. There's lots of just weird handling. Yeah, they would all parse to the same style of AST. And then the only place they need to diverge is when we create these semantics objects that then render into the diagrams. We wouldn't have to have multiple grammars and multiple calls to them, so it'd make it a little cleaner. And I think for the user as well, more importantly even, that it would be a lot more intuitive. Once you do learn, oh yeah, this is where the colons go, this is where the arrows go, it's going to be really intuitive to move between all these different ones instead of like knowing three different grammars, which are all these weird subsets of English. So I'd love to hear from you if you're interested in this tool at all for doing some theory of constraints. I wanted to make it more accessible to developers to use these kinds of systems thinking approaches because I think they're really powerful. So hope you enjoy and hope you found this coding session educational. With patience, the most tangled cord may be undone. Thank you.